Okay, so the first thing I want to do, let me know if you want to go over any of this again before we hit the ground running. Last time we wrote constructor, insert, print, size, and find. So we actually plowed through quite a lot on Monday. The first thing I want to do is I want to make our class a little more generic so that it's easy to modify. Maybe I shouldn't have used the word generic because if you know Java, that's a technical term. I mean that in the most general sense. So I want to make it so that as the programmer of this class, it's very easy for me to go in and say, okay, instead of having a simple list that stores ints, I want to change this into a simple list that stores inventory item objects, for example. So what I'm going to do to make that happen, hopefully you're already thinking that you know what I'm going to do. I'm going to create a value type. And so then everywhere I see int in my class, I'm going to change it to value type. That way, if I come back tomorrow and decide I want to have this class contain inventory item objects instead of ints, all I have to do is come right here, change this int to inventory item, and I'm done. Okay, so not type that. Value type. Value type. Value type. Let me know if I missed one. Why is this not working? It's not letting me click on the Zoom. That's weird. Let's try it this way. All right, that's truly bizarre. Oh, there it goes. Okay, I don't know why it wasn't working. Okay, sorry about that little pause. Any more ints that we need to change in here? Okay, so here on this one, value type is defined inside the simple list class. At this point where you see the highlighting, if you recall from our last lesson on templates, etc., that is considered still outside the scope of the class. So instead of just saying value type, I'm going to have to say simple list : value type, so it knows where to go find value type. Here. And then here. Right. So now you can see why I didn't want to just put 0 here, right? Because now what's being called there is the constructor, the default constructor for whatever type that happens to be, whether it's int or inventory item or feet inches or fraction or date. It's going to call the default constructor for that type. And so it's going to return the default value for whatever value type is. All right. Any questions about that process I just went through? I think that should be pretty straightforward. If nothing else, because really it's exactly the same thing we do with constants, except we're just doing it for types now, right? Okay. Next. Let's go back to our client. Looking down here, I see that the next function that I want to work on is the del function. Why don't I call it the delete function?
The delete function is already in C++?
Right. Delete, the word delete is an operator in C++. And so obviously I can't use it as the name of an identifier. So I'm just going to call it del. Okay, so just taking a look here, you'll notice that there's some similarities here between what we're doing here and what we did with the find function. There's going to be two arguments. The first one's going to be the number that we're wanting to delete from the simple list object. And then there's going to be a second argument that's a Boolean that just tells us whether or not that value was found. Okay, so what I'm doing here is I'm saying, okay, if we found that item in the list, then I'm going to print the new list. If we don't find that in the list, I'm just going to print a statement that says that the number we're looking for is not in the list. Any questions about how this client is working here and what the expectations are for our del function? Just deleting something from our simple list. Okay, so let's go to the header file. What's the return type going to be? I did not do that well. Try that again. So I wanted to bring the client up here so that you could see the function call, because that's what you need to see in order to figure out what the return type is going to be. Right, so looking at this function call, you should be able to, sorry, hold on just a second. You should be able to tell just from that function call whether it's a value returning function or not, right? Yeah, so in this case, there's no value being returned, obviously, because I don't use that as an expression. I'm just using it as a statement. So this is a void function. And then the parameter list is exactly the same, except I'm going to call this delete. And there's no const because the del function is going to change the calling object, right? It's going to, or the intent is that it's going to change the calling object by removing something from the list. So we do not want const. Okay, so I think that's good for our header file. Let's go to our implementation file. Okay, so here we are. Let's take a look at our diagram. right? So here's just an example of a linked list. And so as we're working on this, let's just imagine that the 19 is what we want to delete, okay? The node with the 19 in it. I'm going to do that a lot, actually, just to kind of give you advance warning. I'm going to say, for example, the 47 points to the 19, when really what I should say is the next data member of the node that contains 47 is pointing to the node that contains the 19, right? But it's a lot easier to just say the 47 points to the 19. So we'll use that sort of shortcut terminology. Okay, so the way we're going to do delete is, first of all, it's going to be very similar to find in a lot of ways. Let me just point out, though, that your first instinct, if you're really thinking about this, would probably be, well, maybe I can use my find function to find the node, so I don't have to rewrite all of that code, and then I just delete it once I found it. There's a couple problems with that. The main one being our find function doesn't return the location of the node. It just returns the actual data that was in the node. So the find function is not going to help us here. We're going to have to start from scratch. So here's what our strategy is going to be. I'm going to create a new pointer here. I'm going to make it point to the first item in the linked list. Or to say that in another way, I'm going to make it point to the same thing that list is pointing to. And then I'm going to move this down the list until I find the node that I want to delete, just like we did with find. The problem, though, is, well, so let me ask this. What do I actually need to change in this picture to accomplish the task of deleting the 19 from the list? What needs to change?
The pointer locations.
Okay, you wanted to tell me exactly what I would have to change in my picture.
I assume you mean you're removing it from the list entirely and not replacing 19 with a blank value?
Correct, yeah.
Okay.
I mean, there is no such thing as a blank value, right?
Well, I mean, I don't know.
You could have a special, yeah.
I don't know, a null character or something.
Right, right.
You'd make the next of the pointer on 47 point to the one ahead of 19.
Right, so I want to make the 47 point to the 62 using our shortcut terminology. Right? Really, if I just make that one move, I have deleted the 19 from my list. That makes sense to everyone? Anyone need, I mean, that's our most fundamental starting point here. So if that doesn't make sense, let's talk about it some more. Okay, good. So, and then of course we would also need to deallocate this node because otherwise we would have a memory leak, right? But that's kind of a detail that that we'll take care of. But I wanted to make sure you realize the main thing is we need to make this, the 47 point to the 62. What that means is that when we want to delete the 19, we don't want a pointer to the 19. We need a pointer to the 47 because we're going to be changing something in the 47 node. All right, so another way of saying that is our goal here is going to be to get a pointer to the node before the node that we're actually trying to delete. Any questions about that? Anybody want me to work on that some more? Okay, so what that means is I'm going to do is the same thing I did in find. I'm going to create a node, a pointer to a node, but I'm going to call it prev pointer. Because it's going to be pointing to the node before the node that I'm actually looking at. Okay, and then I'm going to create a while loop now that is just going to keep moving down the list until one of two things happens. I'm going to keep moving down the list until either I find what I'm looking for or I reach the end of the list. Okay, so while prev pointer arrow. So let's take a look here. I want you to help me figure out what to type here. What I want to type here is while not found. While delete me not found. Okay, everyone understand the concept there? But how do I say delete me is not found? What I want to say is, while prev pointer's not pointing, let me say that. Let me try that another way. While the node that prev pointer is pointing at is not the node right in front of the value we want, the delete me. While prev pointer next not equal to target. So if I said while prev pointer arrow next not equal to delete me. Okay, so if I'm looking for the 19, that means I'm gonna look at the 47, prev pointer, well, okay, actually, let me back up. I read that wrong at first. So let me try that again. This can't be right because delete me is of type value type, and next is a pointer. So what is it we need here? Let me put it out there and see if this makes sense. While prev pointer arrow next arrow data is not equal to the thing we're looking for. Okay, so I couldn't just say data here, because that would mean while prev pointer's not pointing at what we're looking for. That's not what I want. I want to say while prev pointer dot next is not pointing at the thing we're looking for. So prev pointer arrow next arrow data. Okay, so in this case, and this is a little, I feel a little, I sort of wish I had more nodes here so that this wasn't the case, but it turns out that this is going to be false the very first time, right? Because the very first time we enter the loop, prev pointer arrow next. So prev pointer arrow next is that arrow. Arrow data is the 19. And so I'm this whole time we're going to be using the example of 19 of delete me being equal to 19. Okay, and so I'm hoping that it makes sense why this is the correct way to say that. And we're not done because we also want to say, and we haven't reached the end of the list, but this is how we say while we haven't found what we're looking for. Anyone want me to talk more about that? Okay. And prev pointer arrow next not equal to null pointer. Okay, Any questions about that? When prev pointer arrow next is equal to null pointer, that means that the thing we were looking for is not there and we want to stop. Okay. There's one problem with the way I have this while loop condition written that I want to solve before we move on. And that is, if the item is not in the list, this is going to cause my program to crash every time. Because here's what happens. You need or right. No, it's definitely and. I want to keep going as long as I have not found what I was looking for, and also I have not reached the end of the list, right? So when you reverse that, you say, I want to stop when I find what I'm looking for, or I reach the end of the list. But that's not the way while loops work. We don't want to know. While loops aren't based on when you stop. While loops are based on when you keep going, right? So sorry if I went off on that a little bit, but that's super common mistake that students make. So just make sure you say this in your mind. I want to keep going as long as I have not found it, and also I have not gotten to the end of the list. If you've taken discrete structures or anything like that, if you've ever heard of De Morgan's law, that's what we're talking about. If you haven't heard of De Morgan's law, don't worry about it. I just wanted to put that out there in case anyone has. Anyway, so that's not the problem. Let's see what happens if we're looking for something that's not in the list, okay? So let's say that prev pointer, I don't want to start from the very beginning, but let's say prev pointer is pointing at the 19. And I say prev point, and I'm looking for the number 200. Prev pointer arrow next arrow data is 62. So it's not equal to 200. So that part of the condition is true. Prev pointer arrow next is not equal to null pointer. So that part of the condition is true. So I'm going to execute the statements inside the while loop. The statements inside the while loop, I should have said this, but I didn't. Just move the pointer down one, right? So now I'm going to move the pointer down one. Okay. And so the next thing I do is I say, while prev pointer arrow next arrow data, but now right at this point in my picture, if I say prev pointer arrow next, prev pointer arrow next is null pointer. So what I'm trying to do here is I'm trying to say arrow data on something that's a null pointer. So here's the solution to that problem. I'm just going to reverse my two parts of this condition. So I'm going to put the prev pointer arrow next not equal to null pointer first, and then check to see if I found what I was looking for. Okay, so sorry that took a while, but basically I have just reversed the two conditions, okay? So now what happens is if prev pointer is pointing at the 62, I start by saying, okay, while prev pointer arrow next is not equal to null pointer, well, it is equal to null pointer, so that part of the condition is already false. So I don't even have to bother trying to evaluate the second part of the condition. And so I'm okay, I just exit the while loop. Okay, any questions about that? So this is what I just described to you is called short circuit evaluation. It just means that if the first part of the, if I can already figure out the value of this entire condition by only evaluating the first half. So you evaluate the first half, I already know the whole condition is going to be false. So I don't even try to execute this part, which means that I'm not going to, my program's not going to crash because I'm not going to try to say null pointer arrow data. Okay, that was a little bit of a digression. I could have just done it right the first time and not said anything about it, but there you go. So inside here, we're just going to say move prev pointer to the next node in the list, right? So if it's like that, move it so it's pointing at the 19. And the way we do that is we say, okay, make prev pointer point to the same thing that prev pointer arrow next is pointing to. Make prev pointer point to the same thing that prev pointer arrow next is pointing to. Okay, and so the result of that statement is that advance prev pointer one forward one node in the list. Okay, any questions about this loop? So here's what I can say about this loop. After I'm done with this loop, I can say either I found delete me, or I reached the end of the list. Right? One of those two things has to be true. Otherwise, I would still be in the while loop. So now what I need to do is I'm going to need an if statement to try to figure out which of those two cases it is. So I'm going to say if I reached the end of the list. How do I say that? What's going to be true if I have reached the end of the list? And that's why I exited the while loop.
Previous, okay.
Yes, thank you. Prev pointer arrow next is equal to null pointer. If prev pointer arrow next is equal to null pointer, that means the thing I was looking for was not in the list. So all I do is I just set found defaults and I'm done. Okay. Else, so now what I know is that prev pointer arrow next is pointing to the node that I want to delete. Okay, so in the case of, if we're trying to delete the 19, that means that prev pointer is actually still pointing here. And I want to say, make prev pointer arrow next, which is currently pointing at the 19, make it instead point to the 62, right? So how do I do that? Make prev pointer arrow next, point to the node that the 19 is pointing at. In other words, make it point to the same thing that prev pointer arrow next is pointing at. Yes. Okay, so the result of this statement is going to be this. Okay, by the way, you may have noticed that there's no way that we could make it through this lecture without drawing diagrams, right? And I'm going to very strongly suggest that no matter how easy you think the function is that you're writing, just draw yourself some pictures exactly like this one so you can really see exactly what's going on, because it's hard, right? A lot of students just have a super hard time with it. So just take your time, go slow, draw the pictures, make sure that you've got everything right all the time. Okay, end of pep talk. Any questions about why that's the right thing to do? What do we still have left? What did we neglect to do?
Deleting the memory.
Right, we need to deallocate the 19, right? And so the way we're going to have to do that is we're going to have to get a temp pointer pointing to the 19 before we move this pointer to make it point at the 62. And then we're going to delete that temp pointer when we're done. So node star temp pointer gets prev pointer arrow next, right? Because at this point, the picture still looks like this. Okay, so I'm saying node star temp pointer gets prev pointer arrow next. So this diagram is going to get a little scary, but I'm saying create a new pointer on the stack. So it's an automatic local variable. Make it point to prev pointer arrow next. Okay, then prev pointer arrow next gets prev pointer arrow next, arrow next. Right, and so now I just need to deallocate the 19. Okay, and the result of delete temp pointer is just that, I could erase this, but I think it's actually more, memory doesn't actually get erased, right? What's really happening there is I'm just saying, okay, this is now available. You can go ahead and use it for something else if you want. I'm going to note that by just coloring it yellow, just to indicate that it has been deallocated. Okay, and that's it. We're at the end of our function. Any questions about the del function or any thoughts about anything, any problems you might see with the del function? Okay, so here's where something I said on Monday comes into play. On Monday, I said, remember, when you are writing a function that is manipulating linked lists, you're going to have to go through sort of the standard list of all the possible special cases or boundary cases to make sure that your code works in all of those special cases, right? So basically what we have here, we have a del function that works for the general case. If we've got a lot of nodes in our linked list and we're trying to delete a node somewhere in the middle of that list, this code works. That's the general case. Okay, but we need to ask ourselves, does this work when it's an empty list and I call del? Does this work if I'm trying to delete the last item in the list? Does this work if I'm trying to delete the first item in the list? Does this work if the list only has one item in it and I'm trying to delete something other than what that item is? Does it work if there's only one item in the list and I'm trying to delete that node? That's all I can think of at the moment, but you get the idea, right? So let's start with, does our function work on an empty list? So just ignore all the rest of this picture. Imagine that list is equal to null pointer. I'll just move this aside for a second here and we'll make it official. Okay, list is null pointer. Is our function going to work? What's going to happen?
I think it's gonna work.
Right.
Because it's not gonna get inside the loop, and we have the if.
All right,
Condition.
let's take a look. So first thing we do is we say node prev pointer equals list. So that means now prev pointer is going to be null pointer, right? And then the next thing we do is we try to say prev pointer arrow next. That's not going to work if prev pointer is equal to null pointer. Everybody see that? Anybody see that? Does it make sense
Yes.
that, okay. So here's what we're going to do. We're going to have to put this whole thing in an if statement. And this is very common in linked list code. You're going to just have a series of if else's to handle all of the special cases before you get to the general case. So if list equals null pointer, then all we need to do is just set found equal to false and we're done, right? Else the rest of this. All right, any questions about what I just did? Now we have successfully handled the situation where list is an empty list, or where the calling object is an empty list, right? From the perspective of the client, what's happening here is I have called the del function with a calling object that is an empty simple list. And there's nothing wrong with that, right? We're not saying that should cause an error. We're just saying that if you do that, I'm going to set found equal to false, just to let you know that I didn't delete anything. Okay. Anybody want to take a shot at if there's any other special cases we need to worry about? I will give you a hint. There's one more.
So if we reach the end of the list, since we're like using the previous, or I guess, so if it's the end of the list and we delete it, and then we try to say, like we try to make, so like, let's say we're trying to delete 62, and then we deleted it.
Okay.
We would then, our next line of code would try to make 19 point to what 62 is pointing to, but 62 isn't actually pointing to anything, so that would be a problem.
Well, let's
Right?
trace through that. I mean, the short answer is we're not deleting the 62 until after we've already assigned prev pointer arrow next. But
Yeah,
that's a great question. And even if someone hadn't asked it, I was going to do this next. Let's see what happens when we're trying to delete the last item in the list, because that's it. Oops, that is not at all what I meant to do. That's an important thing to check. Okay, every time you write a linked list function, you should be asking yourself, is this going to work when the node that I'm processing is the last node? Okay, what I meant to do here was I want to put this back in the list, so I want it not to be yellow. And I want list to be pointing to 7. So I'm trying to go back to my original list. I will get there eventually. 47 needs to be pointing 19. Okay, so I think that's my original list. Temp pointer doesn't exist yet. And so let's see what happens if we're deleting the last item. What's going to happen is we are going to stop when prev pointer is pointing at the 19, right? Because at that point, prev pointer arrow next will be, I'm sorry, prev pointer arrow next arrow data will be equal to delete me. So that makes the loop stop. So now let's see what happens when we try to execute our if statement. If prev pointer arrow next equals null pointer, does prev pointer arrow next equal null pointer in our picture right now?
No.
No. So we're going to do the else part. So now we create our temp pointer and make it point at the thing that prev pointer arrow next is pointing at. Whoa. Right? Then we say prev pointer arrow next gets prev pointer arrow next arrow next. So we're prev pointer arrow next is this cell right here. And we are going to put something in there, right? It's on the left side of the assignment operator. So we're replacing it with something. We're replacing it with prev pointer arrow next, which is this cell. That cell is now null pointer. So the result of this assignment statement is we're going to make this guy equal to null pointer. And that turns out to be the right thing, right? Because this is now the last node in the list. So we want its next data member to be equal to null pointer. And then we delete temp pointer. So this turns yellow. Okay, so excellent exercise, something you should always do. In this particular case, we found out that if we're trying to delete the last item in a simple list, the general case already handles that correctly, so we don't have to have a separate case. Okay. Any other special cases that we need to worry about here?
I guess one other problem is that if we're at the beginning of our list, since we're checking prev pointer next data, we won't actually check if that current first node contains our delete me data.
Okay.
So
So
it might skip over it.
okay. So the thing we want to know if our function works correctly if delete me is the first node in the list, right? So let's give that a try. Let's see what happens if we are trying to delete 47. Let me make all this go back to what it was before. Does that look right? I get everything? Oh, except this prev pointer hasn't been assigned to anything yet. We'll say, okay. So let's see what happens. Node star prev pointer equals list. So that make prev pointer point at the same thing list is pointing at. And then we get into, let's see, list is not null pointer. So we get into our while loop. While prev pointer arrow next is not equal to null pointer, it's not. And prev pointer arrow next arrow data is not equal to delete me. So that's while the 19 is not equal to delete me. So we never even looked at the 47, right? So turns out that is another special case we're going to have to handle separately. Let me suggest that when you discover a special case, the best thing to do is to just create a new branch in your if-else statement. If you try, a lot of times students will try to just kind of add some code inside this branch that's going to take care of that. And it usually turns out to be a bad idea, okay? You might end up with code that's like slightly more concise, but you're much more likely to introduce a bug and spend hours and hours trying to figure out what's wrong. Better to just create a new case. So we're going to say, else if the first node contains delete me. Right? Everyone understand the condition? List arrow data is the data member of the first node in the linked list. So if the thing we're trying to delete is the first node in the list, what do we need to do? In my picture, what needs to change? Without worrying about deallocation for now, just, the first step is to just, what needs to change in order to make it so that the 47 is gone from my list?
Make the list pointer point to next.
Correct. Right? That's it, I'm done. I still need to figure out how to deallocate this, but that's a detail I will take care of in a minute. So for now, let me just say list. I'm changing what this pointer inside the list variable is pointing at, right? Instead of pointing at the 47, pointed at the 19. So list gets list arrow next. Okay. Now, we need to deallocate this, so we're just going to use the same technique. We're going to introduce a new pointer variable named temp pointer. Make it point to list, right? And then after we move list, delete temp pointer. Okay, I see a question in the chat, but first I just want to make sure everyone gets this. Any questions about why that works? If we didn't care about memory management, if we didn't care about memory leaks, it would just be this one line of code, right? But we're going to be good memory managers, so we're going to create a temp pointer that points at the node we're deleting, and then when we're done, we're going to deallocate that node. Okay, so interestingly, just now as I was talking about this is the first time I noticed that we already have prev pointer pointing at list, right? So we actually don't need to create a new node pointer. We could just say delete prev pointer, right? Prev pointer is already pointing at the node we want to delete. I'm going to argue that it's probably better to just use this technique, just because if you're in this part of the code, if I'm reading this function and I'm trying to understand what's going on, I'm going to get to the delete prev pointer, and I'm going to be saying to myself, what does prev pointer have to do with this? I haven't even started looking through the list. So I think it actually, in my opinion anyway, will be more readable code if we actually go through this process and not make the reader go back, look at what prev pointer is pointing at, and try to figure out why it works to just delete prev pointer. But you are right, that would be correct code. Okay. Any questions about all of this? All right, so I think we should test this function. Pretty involved, right? Took us quite a while to write this. Don't be surprised if you find yourself in the same situation in your last lab of the semester. It's going to be super important that you just, take it slow, draw the pictures. If you're not like super confident about pointers and what delete does and what new does, I just have to say that you're going to be at a big disadvantage. You may want to go back and review that a little bit. So anyway, let's give this a whirl, see if it works. Unknown type and value type. Did I do that? Oh, I forgot to put my scope resolution operator here, right? Everyone clear on what just happened? No questions? There. One missing word and I got 10 errors. Okay, gonna insert a bunch of numbers. Not gonna find anything because we already tested find. Number to delete. Let's delete a number in the middle first. Uh-oh. That's not good. Okay. What did we do? Oh, I know what we forgot. We forgot to say found gets true if we do find it here and also here. You would think that I would just pay closer attention to my notes. All right, let's try that again. Okay, delete the 3. Looks good. Let's try deleting the first item in the list to make sure that works. Let's try deleting the last item in the list to make sure that works. I'm trying to give you an idea of when you're testing your code, sort of what you're going to be thinking, right? All right, let's just get rid of these numbers now because I want to see what happens if the list has only one item in it. So now there's only one item in the list. Let's make sure that it works when there's only one item in the list and I try to delete something other than that item. That works. Now let's delete the item that's the only item in the list. Now it's empty. And then if I still try to delete something on an empty list, that's also going to work. So it looks like we're in good shape here. Any questions about any of this? Okay. So I need to take a break, and then by the time we get back, we're going to have 10 minutes left, and which is not really enough time to get very far on what is next. So I think what I'm going to do is I'm going to go ahead and just call it a day, and we will wrap up the simple list class on Monday. I think you should be able to get started with your assignment. Basically, the thing that we have not done with the simple list class yet is the big 3. That's all we have left to do. But that's a little bit involved, so you may want to wait until the lecture on it before you try to do the big 3 yourself. I'm kind of assuming that most of you are probably not going to be starting that assignment quite yet anyway. But if you wanted to get a start on it, you could certainly do that with what we've talked about so far. Okay, any questions before we go? I think you guys have lab at 4, right? Go ahead.
I just have a quick question. Well,
Sure.
not really a question, kind of a request. Can you make sure to upload the recordings of these, please?
Okay, yes, I will do that. If they're not there, later today, feel free to email me and remind me. Unfortunately, I have another class today right after this, so I probably won't have time to get to it right away. I will try really hard to remember to do that later tonight.
Thank you.
Okay. Have a good lab, and I will see you on Monday.
Have a good day.